So in this video, I will go over more in depth in a matrix and how to change a matrix to look in a certain way, such as row echelon form and reduce row echelon form using row operations. In this video, you will learn the sequence of operations performed on the associated matrix of coefficient, define pivot positions, and columns in details. You will understand how to write a general solution and distinguish between a basic variable and free variables. So this section is called reduced row echelon form. Okay? So in previous math course, you have learned to solve a system equation several ways, such as graphing, substitution, elimination, and in your college algebra, you should have learned Cramer's rule. In this course and lecture, you will learn a new method to solve system equation using matrices. You'll write an augmented matrix and you will manipulate it to make the matrix look a certain way using row of operations. So there's two ways you want to make your matrix look like. You can make it look what's called row echelon form, or also known as Gaussian elimination. And you can also put it in reduced row echelon form, or known as Gauss-Jordan elimination. Okay. So yeah, our goal is to put the matrix in either of these forms, and you'll have your solutions. So solving a system using matrices, what's the easiest / best ways to have? So if you could have a matrix, it's best to have it in a square matrix. So if you look at this example, we have x equals a, y equals b. And we have to somehow put that in an augmented matrix. So we go by rows, we go by columns. So this column is x and this column is y, and then we just use the coefficient. So on the x column, we have a coefficient of 1, right? So if you look here, x has a coefficient of 1, so that's why I put a 1 here. And then on the second equation, there's no x, that's why I put a 0 here. And then on the second column y, on the first equation, we do not have a y, so that's why I replaced it with 0. And then on the second equation, we do have a y, and it has a coefficient of 1. And remember in the previous lecture, if you have in an augmented matrix, you can replace the equal sign with a straight vertical line. And then that's why we have an a and a b. So I like this one. This is a 2 by 3. I like this one because all you have to do is get zeros here, a 0 here, and then you have to make this a non-zero. So identity matrix, or a square matrix, since it has 2 rows and 2 columns, is probably the best. Okay, so when solving a system using matrix, you want to get an identity matrix. Okay, so you can put it in row echelon form. You can abbreviate it as REFF. So whenever you see the term REF in this lecture, it's row echelon form or Gauss elimination. Okay, so in Gauss elimination or row echelon form or REF, what you want to do is make these numbers, these diagonals, into ones, and then under each column there has to be all zeros. So under the column, not necessarily above. So on this column, see how this number is 0 and this is 0. That's what you want. And then under this, we call this a pivot point, this 1. Make sure anything below that is 0. And then make this a 1. And then everything above, you don't have to make it 0. It could be a number. I don't really like this form, is because you would have to do some substitution. You have to do some back substitution. And it just requires more work. So yeah, like I said, create an upper triangular. So this is just the rules. You want to create an upper triangular matrix. So basically you want to make these all ones. See how it forms a diagonal? You want this diagonal to be all ones, and then everything below to be 0. Above is fine. It doesn't have to be a 0. It could be a non-zero. The same thing with here. This is a more complex, but same rule. Make these diagonals ones, everything below 0, and then everything above can be non-zeros. Yes, so just like we said, everything below the 1 in each column must be a 0. Reduced row echelon form is or RREF. So if you see RREF, that really means reduced row echelon form. And it's also known as Gauss-Jordan elimination. I prefer this method because there's no backup substitution, and it's a little bit more work than the other form. I forget, row echelon form, because this time everything above the ones and below the ones has to be 0. So you look at this matrix, this is 3 by 3. So you make these diagonals into ones, and then everything below the ones and above the ones should be zeros. This is all zeros. This is a 0, and then above the 1 also should be 0, and then this should be zeros. So that's the only real difference between reduced row echelon form and row echelon form. Okay. And why do I prefer this? Why do I prefer reduced row echelon form? Is because you no longer have to do back substitution. Okay, so everything what I just said is what I just said. And so yeah, everything above and below must be 0. So here's an example. Here we have a system of equations. We have 1, 2, 3. We have 4 system of equations, right? What you want to do is it's kind of been solved, but it's kind of giving you ideas. So what you would do first in this system of equation is convert this system of equation into an augmented matrix. So just look at it vertically column wise. So this column 1 is x1, this column is x2, this column is x3, and then this column is x4, right? And then you just go down vertically and you use only the coefficients. So starting with x1, this has a coefficient of -1, so that's why, whoops, over here we are missing a term, right? On this system equation, this does not have an x1, that's why we put a 0. And then just go down vertically. And then this has a coefficient -1, so this is why this is a -1. This one has a coefficient -2, etc. And then you do the second column, x2. And you just use the coefficient. You have -3, -2, -3, 4, etc. x3, -6, -1, etc. And then the same thing with x4, you use the coefficient. If you're missing anything, replace it with 0. And then this equal sign, you can represent this equal sign as a vertical straight line, just like that. And then just on the right side, this is your answers. Which is what equals 9, 1, -1. Okay, so first I would make your augmented matrix, and then I'm gonna you can either put it in row echelon form or yeah, you can put it in row echelon form or reduce row echelon form. So in this example, they put it in row echelon form. See how everything above the ones are not necessarily zeros, right? So here's your diagonals. And yeah, so also, this is also very important. If you want to put it in Gauss-Jordan elimination, the last term has to be 0, and then this has to be 0. So this whole entire row has to be 0. If it's not, it usually means there's no solution or infinitely many. Okay, so what are pivots? So a pivot column, usually a pivot columns are usually done after you simplified either in row echelon form or reduce. Pivots are basically free variables since there's no number one free to be whatever they choose. So pivots are found after row reduction. So after you do your reduced row echelon form or Gauss-Jordan elimination, um, and pivots are like x1, x2, x4. So these are all pivot columns. So this whole thing's a pivot column. This whole thing's a pivot column. And I believe the pivots are just the diagonals. So this is a pivot, this is a pivot, this is a pivot. So pivots are the diagonals. Pivot columns are the columns after you simplified. Okay, so now you know the two forms. Now, how do you just you can't just magically make it look like this, right? You're going to do some algebra. You're going to manipulate it by using what's called row operations. Okay, so how you do row operations? One, replace. You can only you can replace, meaning you can switch rows, right? Or no, actually, sorry, that's not what I meant. Replace is meaning you can add two rows. Yeah, you can add two rows. Um, you could put a minus in front of one of the rows, but that's not exactly a subtraction. You can also interchange. So you can switch row one with row two. So notice I say rows. We're not mixing the columns. We're just messing with the rows. And when you do order of operations or row up operation, you can only I would only do one row at a time because it can get confusing. When you're multiplying by scalar, that's when you can do you can multiply a row scalar more than once, and you'll see what I mean. So yes, you work column by column. So do not move to another column until you gotten all the necessary zeros. Once you have all your zeros, then get your pivots, the ones, right? Hint, if you're working in a column one, use row one to get your zeros. If you're in column two, use row two to your zeros, etc. Okay, so this is exciting. Now let's do what we just learned. Example one says use reduce row echelon form to solve the system of equation. Ooh, okay. Okay, so here we have our first system equation is 8x plus 6y equals 2. And then our second equation is 5x plus 4y equals -1. So this one's not too bad because I think it's like a square matrix. Okay. So what your first step is, what's the first thing I would do is write an augmented matrix. Actually, no. No, actually, let's not do reduce row echelon form on this example. Let's just solve it using elimination. Okay. Yeah, we'll do the next example is when we do the matrix. So let's do elimination. How would you do this? Well, you want to get rid of the x or the y's, right? And let's get rid of the x. So here you have an 8x and a 5x. What I like to think of it as, what is my common denominator between 8x and 5x, or the constant 8 and 5, right? Well, the common denominator between 8 and 5 is 40. once you have your common denominator, just make one positive and one negative, and that'll work. So here we have 8, and or 8x. I want to make that, let's make that into a positive 40. So what I would have to do is multiply that by, or actually negative 40. What I have to do is multiply this by negative 5. And then on the other x, we have 5x. If our LCD is 40x, I have to make this into a positive 40x. So maybe I'll multiply this entire row or the entire equation by 8. Right? So now we're just doing elimination. So negative 5 times 8 is negative 40x. Negative 5 times 6 is negative 30y. And negative 5 times 2 is negative 10. And then FOIL out is 8. 8 times 5 is 40x. 8 times 4 is 32y. 8 times negative 1 is negative 8. Okay. Add them up. Negative 30 plus 32 is 2y. Negative 8, negative 10, and negative 8 is negative 18. And then go ahead and solve for y. So you're going to divide this by 2. Y equals negative 9. Okay, now you want to solve for x by substituting your y into either the original equation, not this one or this one. So you want original. So if you put it here, that's fine. So it would be 8x plus 6, and then you replace your y with negative 9 equals 2. And when you do all the work, it's 8x minus 54, and then solve for x. 6 divides by 8, and you get x equals 7. Okay, so your solution is 7 comma negative 9. Okay, so this was elimination. We're going to get the same solution using matrices. So that's what I just wanted to show you. So we're going to get the same solution. You can get the same solution with matrices. So yeah, I'm going to show you how to do it. So let's quickly do it with matrices, and we're probably going to use reduced row echelon form. So if you want to use matrices, the first step is write an augmented matrix. That's the first step I would do. So you've got a problem. We go by columns and then we just use the coefficients. So starting with the x, our coefficients are 8 and 5. And then on the columns y, our coefficients are 6 and 4. And then you have this equal sign, so you're going to put a straight vertical line to represent equal. And then we have 2 and negative 1. Okay. Now that you have your augmented matrix, now you're going to use row of operations to make this matrix look like this. Okay. So you want your pivots to be all ones, and then everything below and above to be 0. And then this is x, this is your y column. Okay, so let's start with column 1. I'm not going to make this 8 into a 1 because I can just multiply it by, at the very end, I can multiply it by a scalar to make that 8 into a 1, right? Instead, what I'm going to do is make this 5 into a 0. So how do I do that? How on earth do I do that? How do I make this 5 into a 0? What you're going to do is use row of operations and So you can either add add two matrices. I mean two rows, sorry, two rows. So 5 is technically in row 2. So what we're going to do is put an arrow and we're going to do row 2 because the only thing that we're changing is the entire row 2. Row 1 will still be the same. 8, 6, and 2 will be the same. So remember, we can only do one row at a time. If you do two rows, it's very easy to make a mistake. So look at the number 8 and 5. What would be the common denominator? 40, right? And then you just have to make one positive 40 and one negative 40. So what I would do is maybe multiply negative 5 is a scalar, by the entire row 1. And then maybe if I would add plus and multiply 8 scalar by the entire row 2. If you add them up, that'll give us your new row 2. Okay, so let's see if that really does work. So what will be our first number for row 2? It would be negative 5. And what's the first number in row 1? So here's row 1, 8. The first number in row 1 is 8 plus 8. And then what is my first number in row 2? 5. So negative 5 times 8 is negative 40. Plus 8 times 5 is 40, which is 0. So you're going to put a 0 right here. Okay, now continue the process, because remember, we're going by entire rows. So the next number would be negative 5. And what is the second number in row 1? Not column 1, but row 1. 6 plus 8. And then what's the second number in row 2? 4. So that would be 2, right? Negative 5 times 6 is negative 30, plus 8 times 4 is 32. Add them up, that gives you 2. Okay, and continue again. Oh, make sure you put that straight line. So negative 5. What's the last number in row 1? 2 plus 8 times, what's the last number in row 2? Negative 1. Negative 5 times 2 times 8 times negative 1 is, I believe, negative 18. And then we didn't mess with row 1, so what you're going to do is rewrite row 1 originally. So our original row 1 was 8. So sometimes you have to go back to your original previous matrix, right? Go to the previous matrix. Do not start from the beginning matrix. And you'll see what I mean when we do more of these. So our previous matrix of row 1 was 8, 6, and 2. Okay, good. Now what would I do next is I'm going to make this 6 into a 0. Okay, I'm not going to make this 2 into a 1 yet, and I'm not going to make this 8 into a 1, right? Because we want it to look exactly like this. Instead, I would just get all the necessary zeros first, because you can multiply rows by a scalar to get it into a 1. So how on earth do I make this 6 into a 0? So 6 is still technically in row 1, so we're going to write it as your final answer is row 1. So what I do is kind of look at the common denominator between 6 and 2. The common denominator between 6 and 2 is 6. And you just have to make one positive 6 and negative 6. So what would I do? Maybe I would do row 1. And then I'm going to do a minus 3 times the entire row 2. So it's like plus a negative 3 row 2. Well, you could just do minus. So let's see if that really works. So what's my first number in row 1? So we're going to look at this matrix. Do not start from this matrix. No. Right? No. You always start on the previous matrix. Okay. So what is my first number? What's my first number in row 1 of this matrix here? 8 minus 3 times row 2. What's my first number in row 2 in this matrix? 0. So what's 8 minus 3 times 0? 8. Now keep on going. What's the second number in row 1? 6 minus 3 times, what's the second number in row 2? 2. And when you put that all together, 6 minus 3 times 2 is 0. Good, that's what we want. We want this to be 0. Continue. What's the last number in row 1? 2 minus 3. And then what is the last number in row 2? Negative 18. What's 2 minus 3 times negative 8? 2 minus 3 times negative 18 is, I believe, 56. Okay. And then 0 to negative 18 stay the same because we can only do one row at a time. Okay, now we're very close. All I got to do is make this 8 into a 1 and make this 2 into 1. So we could do multiply by scalar. And with scalars, you can do it more, you could do it more at a time, like more than once. So what I would do, so to make this 8, to make it 1, you're going to multiply that by, so A is still technically in row 1. And to make this 8 into 1, I'm going to multiply it by the entire row by 1/8. Okay, so you're going to multiply the entire row by the scalar 1/8. And then to make this 2 into a 1, you're going to multiply that 2 by a scalar. And the scalar I'm going to use is the reciprocal of 2, which is 1/2. Okay, so I'm going to multiply the entire row 2 by 1/2. So always start with now we're messing with only this matrix, right? We always go back to the previous. So 1/8 times 8, 1. Perfect, that's what I want. 1/8 times 0, 0. 1/8 times 56, 7. And then do the second row. 1/2 row 2. That's 0. What's 0 times 1/2? 0. 1/2 times 2 is 1. And then what's negative 18 times 1/2? Negative 9. Okay, so now we have it in reduced row echelon form. And I like this. So now our solution is, so remember, we called this the x column and then we called this the y column. So this 1 is like saying 1y, because remember, these numbers are coefficients. 1y, and then the straight line means equals negative 9. And then this 1x equals to this number 7. Okay, so is that the same solution when we did elimination? Yes, we had an x value of 7 and a y value of negative 9. Perfect. Okay. Now you had your first taste of reduced row echelon form. What if it was like a more complex matrix? So let's do example 2. So example 2 says use row echelon form, not reduce row echelon, but just regular row echelon form, or REF, to solve the system. So here's our two system equation: x naught minus 2x2 equals negative 2, and then negative x1 plus 3x2 equals 3. So first step is put in augmented matrix. Okay, so go look at the columns and then go vertically on each column and then look at the coefficients. So starting on this column right here, this has a coefficient of 1, so put a 1 here. This x1 has a coefficient of -1, so put a -1 here. And then the x2 column, this has a coefficient of -2, so put a -2. And then this has a coefficient of 3. And then you have an equal sign, so put a straight vertical line, and then -1, 3. I also forgot to add, when you do these problems, your work might be different from your teacher's work or your friend's work. That's perfectly fine because there's more than one way to do this, right? But the answer should be the same. Okay, so we put in augmented matrix, and if we're going to use what's row echelon form, our goal is to make it look like this. 1, 0, and then 1 here, and then a number there, and then number and a number, right? I don't like this because you kind of have to do some back substitution, but it's okay because its matrix is not too complex. So what you have to do is on this column, does everything below this 1 has to be 0. But on this 1, it no longer has to be, this number no longer have to be 0. It could be a number. So it might save you work in the long run. I don't know. So what are we going to do? We have to make it look like this. We're going to have to do some row of operation to do. Well, first, I'm going to make this one is 1, so that's good. And then I'm going to make this -1 into a 0. So I kind of can see it. To make this -1 into 0, all you got to do is add row 1 plus row 2. You don't have to multiply by a scalar. If you add those two rows, if you add those two rows, the ones cancels, right? Okay. So -1 is technically in row 2, so that's why I'm going to put a row 2 at the very end. And to get rid of this -1, all you got to do is add row 1 plus row 2. Okay. And that'll be your solution. Okay. So you tell me, what's the first number in row 1? 1. Plus, what's the the first number in row 2? -1. So when you add that up, that gives you 0, which is what we want. Now keep on going. What's the second number in row 1? -2. Plus, what's the second number in row 2? 3. So -2 plus 3 is +1. Straight line. Keep on going. Last number in row 1, -1. Plus last number in row 2 is 3. So -1 plus 3 is 2. And we didn't mess with row 1, so rewrite it as 1, -2, and -1, right? Okay, now I think we're good because we said this, under this one is 0. This one right here above doesn't have to be 0. It could just be any number, so we're good. So what is our solution? So if you recall, this column is x1, this column is x2. So let's look at this x2. So this is your coefficient. So this would be expressed as 1 x2 equals to this number 2. So we found what x2 is. Now let's look at these numbers here. What can we do with those numbers? So it's going to be 1 x1, because 1 is your coefficient of the column x1, minus 2 x2 equals to -1. So you kind of have to do some back substitution. Well, we know what x2 is, which is 2. We don't know what x1 is. So it's going to be x1 minus 2 and then replace x2 with 2. And that gives you -1. Okay, so it's x1. -2 times +2 is -4 equals to -1. And then add 4, x1 is 3. Okay, so x1 is 3, x2 is 2, or you could say 3, 2. Okay. Not too bad, right? Not too bad. Okay, let's look at example 3. Okay, example 3 says use RREF, or reduced row echelon form. Solve a system equation. And I don't understand why I didn't write the problem. Huh. So example 3. So let me write out this system equation. I didn't was supposed to be here. So it's going to be x1 Okay, so this is your system equation. I should have wrote it sooner. But so for how do you solve this using RR reduced row echelon form? First step is write it as an augmented matrix. Okay, so you got to stay organized. If you're missing a coefficient, replace it with 0. So look at it vertically and look at the columns and then look at the coefficients. So start with the column x1, right? Here's this x1. This has a coefficient of 1, this has a -1. This does not have anything, replace it with a 0. Or if you're missing anything, just replace it with 0. So it's 0, 1. Okay. So starting with the x1 column, go down vertically, use the coefficient. So this is 1, -1, 0, and 2, right? And then if you do the column x2, it's going to be it'll be 1. And then over here we're missing an x2, so we'll replace that with 0. And then this is +1. This is -1. And then let's look at the coefficient for x3. So it starts with 2. 2, 2, and 1. And then straight line to represent equal. And then it'll be -1, -3, -2, +1. Okay, so that's our augmented matrix. And then your goal is to make it, so we want to use reduced row echelon form. So that means everything below the ones and everything above the ones, and then the last row must all equal to 0. So what that means, it should look like this. Okay. So yes, what you want to do, so here's your pivot, this diagonals. So you want this all to be ones, and then everything below this one should be 0, and everything above. So on this one's, everything below this one should be 0 and above. Over here, everything below and above. And this should be a number, this should be a number, this number, and then this entire row must equal to 0. Everything to be 0. Okay, if it's not, it means it's either only many or no, infinitely many or no solution. So let's start. Let's get to work. So this has a 1, that's good. I want to make this -1 right here into a 0. So I kind of see that if you look at the number above, all you got to do is add row 1 and row 2 to make this to a 0. So go ahead and do that. So keep in mind -1 is in row 2. And all we got to do is add row 1 plus row 2. And then that'll give us your new numbers for row 2. Okay, so start with, what's my first number in row 1? 1, plus what's my first number in row 2? -1. Add them up, gives you a 0. So your first number for your new row 2 is 0. Keep on going. Second number in row 1 is 1, plus second number in row 2 is 0. Add them up, 1 plus 0 is 1. Keep on going. Third number in row 1 is 2, plus second number in row 2, third number in row 2 is 2. So that would be 4. And then lastly, the last number in row 1 is -1, plus last number in row 2 is -3. So -3 plus -1 is -4. Don't forget to put a straight line here. And we didn't mess with row 1 or row 3 or row 4. So remember, we can only do one row operation at a time because it can get confusing. So rewrite row 1, rewrite row 3, and rewrite row 4. So it'd be 1, 1, 2, -1, 0, 1, 2, -2, 2, -1, 1, and 1. Okay. Okay, so we have these 2 zeros. That's very good. Now what I want to do next is make this 2. I want to make this 2 into a 0. So how would I do that? Okay, so this 2 is technically in row 4. So I think all you have to do is multiply 2 by row 1 minus row 4, and that will eventually make this 2 into 0. So multiply 2 by row 1 minus row 4. Okay. Okay, so it's 2, and then we always look at the previous matrix. Do not start with your original. So your previous matrix is this one. So could you tell me the first number in row 1? Yes, it's 1. Minus, what's my first number in row 4? Yes, that's 2. 2 minus 2 is 0. Keep on going. So it's 2. What's my second number in row 1? 1. Minus second number in row 4, -1. So 2 minus that becomes positive, so that's 3. Okay, keep on going. 2, and then third number in row 1 is 2, minus third number in row 4 is 1. 4 minus 1 is 3. straight vertical line. And then it's 2, and then last number in row 1 is -1 minus last number in row 4 is 1. So 2 times -1 is -2 minus 1, that's -3. Okay. And then we didn't mess with these rows, so rewrite it. So this would be 0, 1, 2, -2, 0, 1, 4, -4, and 1, 1, 2, -1. Okay. So now what we have to do is yes. So now what I'm going to do is, so we have all these numbers 0. That's good. Now I have to make here's my pivot. So I have to make this 1 here 0, this 3 0, and then this 1 0. So everything below the 1. So look at the second column. Everything below this 1 should be 0. Everything above this 1 should be 0. So what would I do next? Maybe what I would do is make this 1 into a 0, right? This one is fine. We want this to be 1. Don't touch this. So how would I make this 1 into a 0? Maybe you could do row 1 minus row 2. Yeah, row 1 minus row 2. And that'll give us your new row 1. Okay, so let's look at the previous matrix, so this matrix right here. So could you tell me the first number in row 1, 1, minus the second number, I mean the first number in row 2 is 0. So 1 minus 0 is 1. So this one stays the same. Okay, second number in row 1 is 1, minus second number in row 2 is 1. So 1 minus 1 is 0. Perfect. And then keep on going. Third number in row 1 is 2, minus third number in row 2 is 4. So 2 minus 4 is -2. Put a straight line. And then keep on going. Last number in row 1 is -1, minus last number in row 2 is -4. 2 negatives becomes a positive, so 4 minus 1 is 3. And then we didn't mess with these rows, so just rewrite it. Okay, good. Now that we have this 0 to be 0, this one stays the same. Let's make this one into a 0. So how would I do that? Well, I think all you got to do is subtract row 2 by row 3, right? Or what should I do for I don't want to make a mistake. Three, three. So maybe, yeah, let's make this one. Let's make this one into a 0. 3, row 3. So I I already did this problem, but I just realized you can just to make this one into 0, all you could do is row 2 minus row 3, and then that will give you a 0, because that would be 0, 0, 1 minus 0, 0, 4 minus 2 is 2. But in my notes, what I did was I multiplied 3 by row 3 minus row 4. It's probably more work than subtracting row 2 minus row 3. But I don't want to make a mistake, so I'm just going to do it on my notes. Do what I did on my notes. But on your work, you could just do what I just said. Okay. So could you tell me so it's 3, and then what's the first number in row 3? 0. Minus the first number in row 4 is 0. And I'm looking at this matrix right here, always the previous, right? So that would be 0. And then what's the second number in row 3? 1. Minus the second number in row 4 is 3. 3 minus 3 is 0. And keep on going. 3 times the third number in row 3 is 2. Minus the third number in row 4 is 3. So 3 times 2 is 6, minus 3 is 4. 3 times 2 is 6, minus 3 is 3. Put a 3 here. Straight line. And continue the process. So it's 3, and then last number in row 3 is -2, minus last number in row 4 is -3. So -6, but now this becomes a positive. So -6 plus -3 is -3. Okay, and then we didn't go back to our previous, we didn't mess with row 1, 2. We didn't mess with row 1 or row 2 or row 4, so you have to rewrite it again using this matrix. So this would be 1, 0, -2, 3, and then this would be 0, 1, 2, -2, 0, 3, 3, -3. Okay. Now what I have to do is, now I have this 0. Good. I have this 0. This is my two. Wait, did I think I made a mistake? Yeah, so it's very easy to make a mistake. I'm just looking at my notes and yeah, I made a mistake right here. Here, let me erase. It's very easy to make a mistake. Okay, I think I did this, like I did the robe operation is correct. Um, yes, yes, the robe, this is correct. So I must have done something. So let's redo this. So this is, I believe this is still correct. And so this is our new answer for row three is 3 times row three minus row four gives you row three. So go back to this matrix and let's put it here. So what's my first number in, so it's gonna be 3 times, first number in row three using this matrix is 0 minus first number in row four is 0. So that gives you 0. So the first number in row three should be 0. Okay, keep on going. 3, so yeah. Okay, so its second number in row three is 1 minus second number in row four is, wait, so 3, yeah, second number in row four is 3. So 3 minus 3 is 0. That's good. And then 3, and then third number in row three is 2 minus third number in row four is 3. So that's 3 times 2 is 6. It's 3, that's 3. Vertical line to represent a straight line. And then last number in row three is -2 minus last number in row four is -3. So 3 times -2 is -6. And then two negatives become positive. So that would be -6 plus 3 is -3. Perfect. And then I didn't mess with row 2 or row 1 or row 4. So rewrite it. So row 2 was 0, 1, 4, -4. Row 1 is 1, 0, -2, 3. And row 4 is 0, 3, 3, -3. So rewrite that. So we made this 0, right? Now what would I do next is I'm going to make this 3 into a 0. So how would I do that? Yeah, what you could do is you could do 3 times row 2 minus row 4, and then that'll give us your new row 4. Or there's more than ways you can do this. You can multiply the entire row 4 by 1/3, and then add that by row 3 and row 4, and that can also give you 0. What I'm going to do is I'm going to multiply 3 by row 2, multiply the scalar 3 by the entire row 2 minus row 4, and then that will give us your new row 4. Okay, so go to this matrix, the previous matrix, and okay, so it's 3. And first number in row 2 is 0, minus the first number in row 4 is 0, and that gives us 0. Keep on going. 3, second number in row 2 is 1, minus second number in row 4 is 3. So 3 minus 3 is 0. Keep on going. 3, and then third number in row 2 is 4, minus third number in row 4 is 3. So 4 times 3 is 12. 12 minus 3 is 9. Okay, and then straight line. And then last number in row 2 is -4, minus last number in row 4 is -3. Okay, so 3 times -4 is -12, plus 3, which is -9. And then we didn't mess with row 3, row 2, or row 1, so rewrite it. So you use this previous matrix. So this would be 0, 0, 3, -3. This would be 0, 1, 4, -4. This would be 1, 0, -2, 3. Okay, so what we do, so now we have this 0, this 0. And now what I have to do is so now what I'm going to do is make row 2 to a 0. So what would I do next? So I have this. So on this column, everything above the 1 and below the 1s are 0. Over here, this 3 has to be a 1, but I could do that at the very end, right? So what I have to do is make everything above the 3 zeros and above this 3, below the 3 0. So what should I do first? So maybe I'll make this 4. I'll make that 4 into a 0. So how do I do that? Okay, so what I would do is, I'm going to make this 4 into a 0, And how to do that. So 4 is technically in row 2, right? And I'm going to, let me erase this. Okay. So yeah, I'm going to make this 4 into a 0. And how am I going to do that? By saying -3 times row 2 plus 4 row 3. And that'll give us your new row 2. So what I'm going to do, because you kind of have the idea of how to do order of operations, so I'm just going to put the answer. So -3 times row 2 plus 4 row 3. The first number would be 0. Second number would be -3. Third number would be 0. Straight line, 0. And then we didn't mess with the other row, so just rewrite it. So this would be 1, 0, -2, 3, 0, 0, 3, -3. And then this, well, yeah. Uh, you know what? I made a mistake. Let's actually make this 9 into a 0, right? And this 3 is a scalar, and we're going to make that into 1. Let's make that 9 into a 0. So how would I do that? Because yeah, I already did it. I don't wanna do it on the way because it might mess up my answer. So that's why I'm gonna do it exactly on my notes. Okay, so I'm gonna make this 9 right here into a 0. So how do I do that? So 9 is technically in row 4. See if I make it kind of small, will it drive? Okay, much faster. So I'm going to make this 9 into a 0, and to do that, I'm going to do 3 times row 2 minus row 4, and that will give us your new row 4. So you could do the work, but I already did the work, and I don't want to waste your time. So when you do that, uh, this entire row will be 0. And then I didn't mess with this row, so this is going to be 0, 0, 3, -3. And I didn't mess with this row, so this would be 0, 1, or -4, 1, -2. Now what I would do next is here, so this 3, I'll make that 1 later. Now what I'm going to do next is make this 4 into a 0. So how do I do that? I'm going to do another row of operation. So that 4 is technically in row 2, so we're only going to mess with row 2. And to make that 4 into a 0, you're going to do -3 times row 2 plus 4 row 3. Okay, so that would be, okay, so the first number in row 2, you can do the work, you can pause this video and do the work as we go, but I already have the answer, and so this would be 0, -3, 0, straight line, 0, and then this stays the same, so it's 1, 0, -2, 3, and then this is 0, 0, 3, -3, and it's all becomes 0. Okay, then what I would do next is, so I have this, maybe I should make this -2 into a 0. Right, that's what I'm going to do next. I'm going to make this -2 into a 0. So another order, row of operation, and that -2 is technically in row 1. So that would be 3 times row 1 plus 2 times row 3. So that would be, okay, so the first number would be 3, 0, 0, and then this would be 3, 0, -3, 0, 0, 0, 0, 3, -3, and then this is all zeros. Okay. Then what I would do next is, we're almost there. I just got to make these, my pivots all to 1s. So what you could do is, you could do multiply it by scalar, and when you're multiplying by scalar, you could do it at more than 1 row at a time. So with row of operation, you can only do 1 row of operation, but with scalars, you can multiply more than once. So let's make this 3 into 1 by multiplying that entire row by a scalar of 1/3. So it would be 1/3 row 1 goes to row 1. And then let's make this -3 right here into a positive 1 by multiplying it by the scalar -1/3. And then let's make this 3 into a 1 by multiplying it by 1/3. Okay, so this would be 1, 0, 0, straight line 1. This would be 0, 1, 0, 0. This would be 0, 0, 1, -1. This would be 0, 0, 0, and 0. Okay, now we have it in our form. Right, we want this to be all 1s, and we want everything below that 1s and above that 1s will be 0. And now we can check our work. So remember, this column is x1, this column is x2, this is x3. So we use a coefficient. So this one is 0. Uh, Yes, so this would be, so this rate 0 is like your x4, so that would be, yeah, so this would be x4 is going to be 0. And then right here, this is your x1. Wait, I should have started here. So 1, let me start here. Let's start here. 1 x1 equals to 1. This is the coefficient for x2, so this is 1 x2 equals to 0. And then this is 1 x3 equals to -1. And then we do have an x4. Remember, in our problem, there was an x4. So our x4 is 0. Okay. Okay. We can check it. So what you would do is put it back, your solutions back into one of the system equations. So one of our system equation was x1 plus x2 plus 2x3 equals -1. Let's see if that's true. So we said x1 is 1 plus x2 is 0 plus 2 times x3 is -1. That can be a -1. So this would be 1 plus 0 is 1. 2 times -1 is -2. Does that give you -1? So 1 minus 2 is -1. Yes. So it works. So this is your solution. And yes, yeah, let's take a break. We'll continue this on another video. I'll stop here.